Hey guys, here's a presentation on dissecting microscopes. Hopefully I'll keep it short. I went a little overboard. I got really excited about the mollusk lecture. I'd spent like 5 hours researching old stuff that I used to know on it, so I'll try and keep this a lot shorter. We'll also go over some basic critter anatomy. As always, the canvas is more specifically in depth, but here's some important stuff. So, there we go. Now, what is a dissecting microscope for? You're going to use it for any object that you want to look at that's visible to your eye. So, even if I find a real teeny tiny cave critter, it's like a half a millimeter long, still visible to the naked eye, so a dissecting scope could be very helpful. It's really great for looking at three-dimensional specimens, so you don't have to tear your specimen apart into little tiny bits and pieces. You can look at it as a whole as you take it apart. And it lets you see really small structures in the specimen, such as obnoxious organs that are ridiculously difficult to find and things of that nature. We've all been there. So, dissection scopes versus light scopes, or compound microscopes, basically. So dissection microscopes magnify, I read online, up to like 100, but usually it's 50 to 75 times for total magnification. Meanwhile, light microscopes are really going hard, going ham, and they can magnify up to like 1,000 total magnification. Dissection scopes are for three-dimensional viewing, and so specimens can be whole, which is another reason you don't need that crazy magnification. It doesn't need to be something that's cut into little teeny tiny pieces and stuff. You can see the structure as a whole. So stuff visible to the naked eye doesn't need 1,000 magnification. Light scopes really need like tissues or cells. That's what they're really good for. So you're going to need really thin, usually sliced up parts of specimens, and you're going to need to put them on a slide in order to view them. You don't have to do that with a dissection scope, but with a light scope, you're going to have to put on like a wet mount or a prepared slide or something in order to look at them. So here's a kind of comparison of two rando microscopes. Here's a compound or light microscope. As you can see, it's got a specific stage with clips for holding specifically a microscope slide. And then over here you've got some rando dissection microscope. As you can see, it doesn't really have exactly the same thing. It doesn't need that though. So let's go over the basic parts of a dissection scope. So you've got the base, which is the butt of the microscope. It holds the whole thing up basically, and serves as a counterweight to clumsy people like me. I've knocked over many. So hopefully y'all can see my mouse. Here's the base. It's exactly what you think it would be. Then you've got the arm, which supports basically anything that goes above the base, the eyepieces, the stage, etc. So here's the arm. Functions like an arm. Who would have thought? Then you've got the eyepieces, which have the lenses that magnify the specimen. So you've got lenses here. These are the oculars. And you've got the lens down here too. But yeah. You've got the stage plate, which is where you put the specimen. Oh, come on, mouse. That's right here. That's what this little circle is. That's where you would put it. Stage clips hold the specimen in place. Those aren't on this fancy schmancy microscope, which I'm pretty sure is Dr. Niemeyer's, and Dr. Kendall's, but they are on this rando one. So here's some clips to hold things down, if need be. And then you've got two light sources. So this one has a light source right here, and then a light source right here. When they illuminate through the bottom, a lot of really clear specimens, you know, they got thin skin or something, the light will shine through and it'll illuminate certain structures a lot easier. So that's part of the purpose of the bottom light. This dissection scope has terrifying alien tentacle looking top lights, but that's really nice to have like 2 different sources of light up above so you can see things a little easier, and then I'm sure the light shines through here for the bottom light source. And then you got the focus knob. This looks like the coarse focus knob, which moves this whole structure up and down. And you've got the fine focus knob, which is for small adjustments and does something with the lenses. That's basically parts of the microscope. Now we'll go into a little bit of critter anatomy. There's a bit more on canvas, but you get the gist. So here's some basic anatomical terms using this adorable little pseudoscorpion here. So here we've got distal and proximal. So distal is going farther away from the body, and then proximal is going towards the body. So this is the distal end of the, I can't remember the specific word, of the pinchies of the pseudoscorpion. And then here's proximal of this limb. Then you have anterior to posterior. That's sort of the head is anterior, and then posterior is the rump, the butt. So here's the posterior end, here's the anterior end. And then you got medial and lateral. So medial is sort of like the center line of the body. And then lateral is the outside margins. So this is the lateral end, and then here's the medial end. You've got stuff like the top of the pseudoscorpion is the dorsal part, like dorsum, and then the belly of it is going to be your ventral. So if I were looking at you right now, if you were looking me in the eye, I would be looking at your ventral side, but if I was looking at your back, that would be your dorsal side. And then the sides of the body themselves are the laterals. So when I'm talking about lateral pattern on a salamander, I'm talking about the side, you know, which I do a lot. So that's pretty much the basics of that. Here I uploaded a video of a cute little pseudoscorpion as a tax for your time. I found this little cave pseudoscorpion last week. They're very teeny tiny. This is like the size of my fingertip. Just so you could see what it actually was that we were talking about. So anyways, pseudoscorpion tax for taking up your time. Do all of the work for this week, and I'll see y'all in next time's lectures.